All right, this is the last section of the chapter. Tomorrow we will be doing the chapter review in class. Wednesday I'll go through it with you, and Thursday is the chapter test. Friday is our window decorating, so we won't start a new chapter until Monday. Thursday. Okay, so the last section, this is where it all comes together, at least it is for me, because this is the method I always use to solve systems of equations with matrices. And in order to really explain how it works, it might be easiest to just start the very simple problem and ask how we solve a problem like this. What do we do? Divide by 3, right? The reason we divide by 3 is what we're really doing is multiplying by its reciprocal, right? Because we're trying to get this to equal 1. That's the point of dividing by 3, right? Multiplying by the reciprocal. So yesterday we learned essentially what the reciprocal matrix or the inverse matrix is and how to do it. Today we're going to use that to solve systems of equations. Okay, so as an example, I'm making this up, so I have no idea how clean it's going to be, but if I have a system of equations like this, okay, what I'm going to do is create a matrix equation. And the way that works, you're going to make a coefficient matrix. Everybody see where I got the numbers? And you're going to multiply this by the variable matrix and set it equal to a constant matrix. This is a matrix equation. How we turn a system of equations into a matrix equation. Okay? So I'm trying to isolate x and y. I'm trying to solve for x and y. So just like up here, when we tried to solve for x, we multiplied this by the reciprocal, or the inverse. We're going to do the same thing here and multiply this by the inverse. Remember this notation, when it's raised to a -1, means the inverse. Okay, this is an important part of matrix multiplication. Matrix multiplication is not commutative, which means the order does matter when you multiply them. If I multiply this to the left of this, it is not the same. I should do this to the -1. As multiplying it on the left. These will not be the same. Okay, so what you do, you choose the side you're going to put the inverse on based on the side you do on the left-hand side of the equation. I won't multiply this by the inverse. I'm going to multiply this by the inverse, so it's going on the left side. Which means the inverse has to go on the left side, and it's not this way. It's always the inverse on the left times the matrix, the constant matrix. With me? Okay. If for whatever reason I had put x and y on this side and multiplied on the right, then I multiply on the right. But the way it's written now and the way we'll do it in class is always going to be the inverse matrix times the constant matrix. Okay? For practice, because you're going to have to remember how to do the inverse, I'm going to do this by hand, and then I'm going to show you how to do this in the calculator. Okay? So by hand, this is what x and y equals, because I just isolated x and y by multiplying by the inverse. So I have to multiply the right side by the inverse, the constant matrix. Okay? So I have to find the inverse of this first. So what I do is I find the determinant, -3 minus 8, and I put it as an inverse. -3 minus 8 is -11, right? -3 minus 8, okay? And then I take 1 over that, and then I multiply it by a new matrix, which switches these two and changes the sign of these two. And it's actually the determinant that I multiply by. -4. Okay? So now I'm just going to distribute the negative 1/11th through, and I get 1/11th, 2/11ths, 4/11ths, and negative 3/11ths. That's my inverse. Now I'm going to multiply that by the constant, which is 6 and 8. Okay, now we're doing matrix multiplication, so I take this row by this column. What kind of matrix will I get when I'm finished with multiplying? What will the dimensions be?
2 by 1.
Yeah, it's a 2 by 2, multiplying by a 2 by 1. The 2's match up on the inside, and the outside becomes a 2 by 1, which is what I should get, because you notice that this matrix is a 2 by 1. And this has to equal that. So when I get this matrix after I multiply, I'm going to get the value of x and the value of y. 1/11th times 6 is 6/11ths, plus 2/11ths times 8 is 16/11ths, which is 22/11ths, which is 2. So x is 2. When I multiply this, 4/11ths times 6 is 24/11ths, and minus 24/11ths. I get 0 for y. Okay, let's check it. So this is how you're going to do it on a calculator. Everybody get your calculator out. I'm going to talk you through it. The first thing you need to do is enter your two matrices. This is what we're putting in the calculator. Matrix A is going to be 3, 2, 4, and negative 1. So you go to second matrix, go over to edit, hit enter, make it a 2 by 2 if it's not already, and then go down to your first and enter 3, 2, 4, negative 1. Enter. Okay? Everybody with me? So now we've got the A matrix. We're going to do the same thing now. Second matrix, go over to edit. Go down to B. Go down to B and hit enter. It should be a 2 by 1. This is the constant matrix that we're going to enter. And it should be 6, 8. After you get a 2 by 1. 6 and 8. Okay, now A and B are stored. We want to take the inverse of A times B. So you're going to do second matrix on a clean screen. Where it says names, just hit A, so hit enter. And everybody should have A on their screen so far, like this. Right?
How do you get to that?
You do second matrix, and names should be highlighted, A should be highlighted, just hit enter, and it'll pull A in. So it should just say A. Everybody with me? Now you don't get that? On a clean screen. Do second matrix, enter. Okay. Now, the matrix button you keep hitting says x to the negative 1, right? Just select that, and you'll get a negative 1 on top of the A. So this means the inverse of A. Okay? Do the same thing now. Second matrix, go down to B, hit enter, and you should have this on your screen. A to the negative 1 times B. A to the negative 1 times B. Okay? Hit enter. What are our solutions? 2, 0. That's what we got manually as well. X is 2, y is 0. Okay? You will not learn how to do a 3 by 3 using, or an inverse of a 3 by 3. Let's see if I pulled that up somewhere. It's here. It's pretty complicated to find it manually. So I'm not teaching it to you manually. Okay? So you've got to know how to use a calculator to do a 3 by 3. Web work is all 3 by 3s, and there's one 4 by 4. With a calculator, there's like 5 problems. Each one should take you about a minute. Okay, if you recognize the A matrix is just the coefficients of your system of equations. The B matrix is your constants. You take the A matrix raised to the negative 1 times B. You have your solution. That's it. It's really easy. Okay? But remember, for the test, you will need to know how to do an inverse matrix, a 2 by 2, manually. So don't forget how to do that. Okay? When we do the review tomorrow, you'll have more practice. But as far as web work goes, you're allowed to use the calculator and all the problems, and you should actually, even in the time you have left, should be able to get it done. Okay? Going through the textbook check real quick, those of you who are interested in the answers. In this equation, A, which is a matrix, times x equals b. To solve for x, you'd multiply both sides by the equation by a to the negative 1. When you do this, the right side of the equation would be the second one. It has to be a to the negative 1 on the left side of b, not the right. Order matters. To solve this equation, number 2, you'd find the inverse of this matrix. And do you see how that matrix is on the right of x? So it must be on the right of the 96. So it would be the first one. Question 3, to solve this using inverse matrices, you first need to write a matrix equation. When you write the matrix equation, the element A11 in the matrix on the right-hand side is what value? A11 in the matrix on the right-hand side would be 5. Question 4, order matters in matrix multiplication. True, order matters. And that was 4. Question 5, the presenter was the same in both videos. Who watched the videos? Different? Yes. So that is false. That is it.